All right, let's go ahead and do this one. This is homework number 3 for chapter 5. All right, determine whether 447 is a term for each sequence below. If so, which term is it? All right, so if I want to know if the term 447 is a sequence, okay, I just got to write down. So instead of the term, T of n right here, I just got to write down 447. And I'm going to see if this is able to be divided and subtracted and added evenly into it. All right, so all I have to do is that. So I have to go plus 3. So this would give me, and I'm going to write on the side, 447 plus 3 is 450 equals 5n. So I'm going to go ahead and divide it by 5. And I get my n equals, and this should go in because it's ends in 0. 5 into 0 is 0. 5 into 5 is 45 is 9. So this is 90 times. Right? So yes, this does go in there. And it's term 90. Okay. B, 447. Here, actually, I'll do it over here. 447. So let's see if this goes in. Right, so we're going to go ahead and go minus 24. Minus 24. Right, so 447 minus 20. Sorry, 447. 447. Did I say 427? 447 minus 27. Right, use your calculator or whatever you need. But 447 minus 27 is 428. So we have a negative 5n equals 428. Okay. And is that able to work out? So 428, I know it's not divisible by 5, and it's a negative also. Okay, which means that it's not going to work. So this one is not a term. Okay, this next one. Yeah, I'm a little out of space, so I'll put 447. And I'm going to go ahead and work this out first. I'm going to go ahead and add 6. All right, so 447 plus 6 would give us 453. I'll write over here. So 453 equals, and then this is all we have left. So I'm going to write this as 3n minus 3. Okay, I'm going to go ahead and keep working on this. Plus 3. So 453 plus 3 is 456 equals 3n. I think this is going to work. I'm going to go ahead and divide it by 3. Okay. So 456 divided by 3 is going to give us 3 into 45 is 15, and 3 into 6 is 2. So it's going to be 152. And that's going to equal n because these are going to cancel. So this is the 152 term. Okay, that's for C. For D, again, I'm going to go ahead and use the 447. Okay, I can write it over here as well. Okay, but since I have more room on this side, I'm just going to write it on that side. Okay, so don't worry too much about which side you write on. Okay, so I'm going to go ahead and work on this. So I'm going to go and do a minus 14. Okay, and I already know it's not going to work because I'm going to end up with negative 3n equals 447 minus 13, or 14, excuse me. 447 minus 14, excuse me, it's going to give you 433. Okay, so it may work out, but it's not going to work because it's a negative 433. Okay, and if I divide that by 3, it's not going to work out anyways, right? But even if I divide it and it works out, it'll be n equals a negative number, and that wouldn't work out. Okay, well, that could mean that it comes before the 0, so it could work out, but it doesn't divide. 3 divided into 433 makes, what's that, 144, and 1/3 missing. So that doesn't work out. So this one is not a term. Okay. And the last one. So if I put 447 right here, work this out, I'm going to go ahead and start this with plus 8. So I will have negative 7, and I'm going to go ahead and distribute all this, plus 7. Okay, because that's going to be negative 7n, and then this is going to make a negative, and negative makes positive 7. Okay, and 447 plus a is 455. Okay, and then I'm going to go ahead and subtract 7. So I will get negative 7n equals 455 minus 7 is going to give us 443. Okay, and then I'm going to go ahead and divide it by negative 7. So 443 divided by negative 7 is going to give us negative 64. So actually that does go in, even though it's negative. So n is negative 64. Okay, and which term is that? Well, that's a 64th term before the 0 term. Okay, so that does work. Choose one of the sequences in problem 66 for which you determine that is not, for which is not a term. Write a clear explanation describing how you can show that 4% is not a term of the sequence. Well, it's not a term of the sequence because it doesn't divide evenly into it. I mean, that's the basic, that's the bottom line. Okay, because if, let's just say this one right here, right? Let's take that part. If negative 3n equals 443, if negative 3 can be divided into it, so think about 443, right? So 443 is like, let's just say it's all these numbers here. All right, so if I can divide negative 3 into it, I mean that I can grab 3 of these, and that would be one term. 3 of these and one term. 3 of those and one term. 3 of those and one term. 3 of those. So if I can divide evenly, then that means that I have the right amount of terms. But see, if you go 443 divided by 3, it's not going to divide evenly. 3 into 1, 3 times 1 is 3. 1 left over. 4. 3 into 14 is 4, which is 12. 2 left over, and 23. So 3 doesn't go into 23. Okay. 3 goes into 21, which would be 7, right? But you have 2 left over. So it'd be like me doing all this, whatever it is. But then I will have 2 left over right here. And 2 left over is not going to be the next term. So, okay. So something like that. You're going to have to explain it. This one is not going to be very explainable. And I am not going to write it down for you. I'm sorry. Describe the common difference, which is the sequence generator for each of the arithmetic sequence listed below. Then write the equation for the nth term. So we've been practicing a lot of this. Okay, first term of each sequence is T1. Okay, so we want the nth term. You know what? And you could actually do this with explicit as well. Okay, so I'll do 2 with explicit and 2 with recursive. Right. So let's do explicit first. Right. So first, in order to do explicit, right? Remember, we use y equals mx plus b. Okay, but you can also use t of n equals the pattern, the dn plus t1, or whatever you want to write down. Okay, but we've been using y equals mx plus b. Right, so the pattern is from 4 to 7 is plus 3. And let's see if that's the same. 7 to 10 is plus 3. So I know I have the pattern. So the pattern is plus 3. So it's going to be, so your slope is going to be 3. And then all I need is my first term, or my 0 term. And since this is T1, right, because they say that the first term is the T1. Okay, I need to find the 0 term. So if I'm adding 3, then that means that I'm going to have to go backwards and subtract 3 to find the 0 term. So 4 minus 3 should give me 1. Because I'm adding 3, and I have to go backwards and subtract 3. So that means that my y-intercept, or my b, is going to be 1. So that's my explicit formula. Okay, let's do recursive. Recursive is really easy. Okay, I like recursive. Okay, so recursive, you need to pick any one of these. So I'll pick the third term, right? The third term. This is the third term. Okay, so I'll say T1 equals 13, and T of n plus 1 equals T of n and then I got to figure out what's the pattern. So the pattern is, let's see, from 3 to 8, looks like it's going by 5. And 8 to 13, that is 5 also. So this is going to be a plus 5. So that's my recursive formula. I remember this is recursive, and over here is explicit. So this is recursive right here. This is explicit. And you can do it either way. It doesn't specifically describe. So well, actually, if it says the nth term, then it'll be your explicit. So maybe we should just do explicit, huh? But it doesn't hurt to practice. Okay. And if you want to write this one in terms of the arithmetic term, then you should write something like T of n equals 3n plus 1. Here, that looks a little better. There we go. Okay. Second one, and this is just for practice, so I'm doing explicit and recursive. So what's the pattern here? Let's see, 24 and 19. So what's happening between 24 and 19? Well, it looks like I'm going down by 5, so it's minus 5. And 19 and 14, well, it looks like it's going down by 5. So I have my equation. Remember, it's y equals mx plus b, but we can write it like this. So T of n equals, so what's happening is it's going down by 5. And then plus b, or what's the very, very first term, right? So what's the, not first term, what's the 0 term? Right, so if I had to go backwards, and if this is the first term, second term, third term, I wanted the 0 term. So that means I would have to go backwards. Instead of subtracting 5, I would have to add 5. So 24 plus 5 makes 29. Okay, so this would be plus 29. Okay, and the last one, we'll do a recursive. So pick any term you want. I'm going to pick, let's say the first term. So I'm going to go with, see, this one I messed up. See, I put T1 equals 13, and actually this is first term, second term, third term. So this should really be T3 equals 13. So I messed up right there. Luckily, I caught it when I was looking back. But let's just say I'm going to use the first term. So I'll go with T1 equals 7, because that's what the first term is. Your first term is 7. Okay. And then the rest of it, I'm going to write T of n plus 1 equals T of n, and then what's going on from 7 to 9.5, and 9.5 to 12, right? So it looks like it's going up by 2.5. So 9.5 plus 2.5. Yep, that's 12. So plus 2.5. So then it's going to be plus 2.5. That's my recursive formula.